Is one of the styles of these problems that we did not have a chance to get to an example of yesterday. What happens a lot of times when you have mixtures of sines and cosines and then tangents or cotangents, my suggestion has always been to rewrite everything in terms of sines and cosines. Also, notice that you have a plus sign between the two. A lot of times what that means is that you will have to get a common denominator. So what I'm going to rewrite this out as is we have sine plus cosine over sine times cosine over 1. Remember, I have the habit of never writing theta or x or anything like that, just because in order for any of this to work, that theta value or that value of x of the angle always has to be equal. If they're not, it won't work. Plus, I think it just gets too messy. It's already enough letters as it is. So looking at this, the second fraction, I have multiplying. When I have multiplying, I just multiply straight across. So what's cosine times cosine? Cosine squared. So I get sine plus cosine squared over sine. What is the sign on the left over that you just don't see? 1. To get a common denominator then, what is going to be your common denominator between a 1 and a sine? Sine. Because all I have to do really is multiply the two together. So if I have a common denominator of sine, fraction on the left needs to be multiplied by what? Sine. What's sine times sine? Fraction on the right didn't need anything. What's sine squared plus cosine squared? 1. Which gives you cosecant. That's the trick a lot of times with these. That's the trick where you have to get yourself a common denominator to work yourself through. What's that? Morning, Judah, or afternoon, Judah, sorry.
That's okay. You're excused.
Thank you. Yes, sir.
Is it a good deal of this trial and error? Like sometimes you don't know which ones you have to substitute. I'm not really substitute, but like make it so instead of like say, instead of like cotangent, I put cosine over sine. How do I know when to use that and not to?
It is trial and error, especially first day. Second day also, you will have a little bit of trial and error. After today, you'll probably start to see, oh, if this is the pattern, try this. And that's kind of what I'm trying to get you guys to see here is if you see a certain style, try it this way. If you see another style, try a different way. Like yesterday we had that one problem where it was like sine over 1 minus cosine. In order to get rid of that, I said, hey, multiply by a conjugate. So if you have a fractional denominator that has a 1 plus something or a 1 minus something, the idea is to create that difference in squares because when you do that, you can create a Pythagorean identity. And it's those little tricks like that. Same deal here. I have addition between the two, which means if I want to do that, you're right. Go to all sines and cosines, see if you can create some common denominator and try that. And it's always a good idea if you want to get a starting point. If you have combinations of sines and cosines, and then along with that, a tangent or a cotangent, to rewrite everything in terms of sines and cosines, if possible. Because then you can combine things. You might be able to simplify things and go from there. That's a really good strategy to start with. So if you're just doing that as your first trial, or which might become your first error, you're fine. Okay? Now, another one that I saw, which one was it? 4. On number 4, there's a couple of things that you could do. And I'll show you 2 different ways that I would think of doing this. Notice again that you have secants and cosines, and aren't secants and cosines inverses of one another? I mean, well, I hope so because they are. So in my mind here, I see this part. I see cosine squared times secant squared. Cosine squared and secant squared are inverses of one another. When you multiply inverses together, what do you always get? You get a 1. What's 2 times a half? 1. What's 3 times a third?
1.
What's 2/3 times 3 halves?
1.
What's 7 times 2?
14.
Thank you for paying attention.
1.
So what I would do is this. I'd simplify out the secant squared as 1 over cosine squared. Knowing that if I multiply those two together, that drops and I get secant squared minus 1. Which means that I have a Pythagorean identity then. 1 plus tangent squared is secant squared. Which means if I move the 1 over, I get secant squared minus 1, which is, and I'm done. That's one way that I would think about doing it. The other way is thinking about GCFs. Secant squared minus cosine times secant squared. What do those two terms have in common? Secant squared. If I factor out a secant squared, I get 1 minus cosine squared. What's 1 minus cosine squared? Sine squared. And again, secant squared is the inverse of cosine. So I can say sine squared over cosine squared, therefore gives me tangent squared. So you may not know exactly where to start off at. And in this case, if you rewrote everything as 1 over cosine and 1 over cosine, it might not be as clean. But if you identify that you've got reciprocals, sometimes it's quicker. Okay? Which one?
11.
Sure. How'd you do it?
Secant squared at the end was 1 plus tangent squared.
Ooh.
Yeah.
It'll work. It's just awful.
Except then when we were supposed to distribute the
You have to distribute the negative then, yeah.
So then I ended up with secant squared minus cosine squared minus cosine squared over something. And so then I just pretended like I didn't see the negative and just wrote minus.
Oh, so then you just kind of fudged your way through it thinking that Murphy wouldn't notice.
No, I thought it would make me feel better about my accomplishment. And so,
Can I put it on a split screen? Number 11, right off the bat, there's really not a whole lot you can do. It's forcing you to try to FOIL that. Okay? You could try and rewrite the first one in terms of common denominators and do that route, because then you'll get a Pythagorean identity to multiply in. Or just go ahead straight away and FOIL. I would just FOIL. It's not as clean, but it does work.
That would be pretty easy to do.
You have cosecant minus cosine cosecant plus cotangent minus cosine cotangent. Are you okay with that? Will you be okay with that? Okay. Now, in the middle here, I have 1 over sine minus cosine over sine plus cosine over sine minus cosine times cosine over sine. Now I split them apart. What's up? I didn't. I rewrote that 1 over sine.
wait, sine's
Oh,
cosine
second.
over 1 and
It's cosecant 1 over sine minus cosine, and then you just split the cosine.
How do you get cosine over
Cosine is cosine over 1, and cosecant is 1 over cosine.
All right. First was the cosecant here. Outside is cosecant, cosine here. Cotangent is here. Cosine, cotangent here.
Yeah.
Cosecant is 1 over sine. Cosine here. Cosecant is 1 over sine. And then cotangent is cosine over sine. Cosine and cosine over sine. Okay. What happens to the middle terms?
They cancel out.
Cancel out. You're left with 1 over sine minus cosine squared over sine. Do these now have a common denominator? Yeah. They have a common denominator, which means that I can go ahead and do 1 minus cosine squared over sine, which is sine squared over sine, which is sine.
Couldn't you also do, never mind.
They do get kind of messy, to say the least. I'll get that. What else on here?
8.
8?
That's another one like what we did.
That one? Can I go to a single page now? Woo. Is she picking on you? Sadie.
Let's say it in the corner.
Nobody put Sadie in the corner.
Sixth grade reaction.
He just quoted Dirty Dancing. Oh my god. Of course they don't get the reference.
I don't know. I've never seen the movie. All I know is that line.
He walks in and he goes,
No.
nobody puts baby in shoes. No one puts baby in shoes. And they were completely joking. And then Serena's doing the day assignment, so she can't even. But it's like one of the
You're welcome.
Patrick's-
I am nothing but a beacon of hope in your life of.
Why are the first three words? Why are the first three words?
Be quiet, no, she's emphasizing her favorite movie so much she said she did. Is that right?
This is number 8. Number 8, you set up very similarly to what we did in number 2, I believe. This is another one where I'm going to automatically try to rewrite everything in terms of sines and cosines. So if I rewrite this in terms of sines and cosines, I'm going to get 1 over cosine minus sine times sine over cosine. 8. Now, remember, this first sine value is over 1, so I can just multiply those two together. So I wind up here with common denominator. They have common denominator of cosine, which I get 1 minus sine squared now. And 1 minus sine squared is cosine squared. One of the things you guys might also notice after a while, they're all the same problem. They just switch sines and cosines because you do the exact same thing. Okay, it's a very common. There's really only so many ways to do these problems.
Just memorize them all and you'll be accepted.
Oh yeah, because there's more than one. But there were some other type. At 2:13. All right, see, late. You must not have. You're okay. You're 46. You're much better.
This is the one that was like right after your
Here, save one for your friend, and then make her scared. Nope, it's just another one. This is the sheet that I forgot that I couldn't find when I made the other sheet. So I just made this sheet to hand to you now so you can save it within the other sheet. So there's a lot of sheet going on.
That was better than the other joke.
I can't even move it now. I have to leave.
I want to show you guys another kind of an idea of what to do when you see a certain scenario.
And then Joel's to
Look over at number 36 on the back, and I'll rewrite it here.
Which side is the back?
The one that has the 36 on it.
Oh, yeah, now I see.
Yeah, because there's no room to write there, because I want to do, there's a couple of really good examples on this sheet that we're not going to be working so much off of this one today, but I want to show you a couple other styles of scenarios. This is the verify again. Now, what's nice about verify is that it tells you what the answer should look like when you're done. So at least you have an idea of where to make up as much stuff as you possibly can to see what sticks. So what we generally do 98% of the time is we do what's called a left to right verification, which means I want to make the left turn into the right. Now, if you notice, the left has addition and the right has multiplication. Usually the only way that that can change is because they got a common denominator. Okay? This is a big hint. When you see addition on one side turn into multiplication on another, that usually means you had to do some sort of common denominator in order to make that work.
Is it the same as that word subtraction?
Yeah. Yep. So what I would do here is rewrite in terms of their inverses. 1 over cosine squared plus 1 over sine squared. And then to do that, what would have to be your common denominator between cosine squared and sine squared? Yeah, you just multiply them together. Just like if you were adding together 1/3, 1/2, the common denominator would be a 6 by multiplying 2 and 3. Same property works here. Fraction on the left is missing a what? Fraction on the right is missing a? And what's sine squared plus cosine squared? And isn't that right there the reciprocal property?
Oh, yeah, maybe flip it.
And that's how some of these things will work. You automatically wind up with reciprocal. LeBlanc, what's wrong? You okay? All right. What happens then here is that I could rewrite this as 1 over cosine squared times 1 over sine squared, which is secant squared cosecant squared.
I think I'm gonna like this more because I have a good goal.
Yeah, you guys are goal-oriented people who want to work hard to achieve something. Some of us in fewer steps than others. Bless you. I think you're right. So, another one that you might see is the one directly above it, 34. This one's a little different. A second ago we were talking about, if you, like Hopworth, you just said, same idea if there's subtraction between the two. Well, this one does have the subtraction between the two, but on the other side, it still has the subtraction. So it meant that there was probably never any common denominators taken care of. But what this one does is that if you look at it, you have a cosine squared minus a sine squared. In your mind, like, oh, that's got to be 1. No. Cosine squared plus sine squared is 1. So what it gets, it's not negative 1. So what happens here is you have to look at that in terms of the Pythagorean identity. I want to go from a cosine squared and a sine squared to make 2 cosine squareds, and then a minus 1 at the end. So sine squared can be rewritten as 1 minus cosine squared. We used that trick back in 14, with a couple of the equations, so it wasn't terrible. So you can do this: cosine squared minus the quantity, 1 minus cosine squared, and then you have to just distribute your negative. You get cosine squared minus 1 plus a cosine squared, which gives you 2 cosine squared and a minus 1 at the end.
Yeah.
So this isn't really like that difficult with math.
You did
It's
get
just like
that.
trying to figure out like steps.
It's a
like
puzzle.
yeah.
It's a giant puzzle.
I like puzzles.
It is a giant puzzle. Alright.
You just negotiate your way around it.
You know how to You're gonna lose. Oh, a nice,
If I start like beating my little brother in like board game or anything, I'll start like making up rules, like making
I think we got it. He was trying to teach me how to do this. I'm not. Wait, is that 49?
Yeah, it's 49. Yeah, this is 49. So we'll go back to one of these that are a little bit more complicated. We'll go back to one of these that's a little bit more complicated to go through. No. Remember, you have to do left to right verification. So if I do that, I start with my 1 plus cosine over 1 minus cosine. These are not written in terms of Pythagorean identities, which means you have to create one. What do you multiply a 1 minus cosine? A 1 plus cosine. Remember, you're going to use that trick of difference of squares. When you do that, your denominator becomes 1 minus cosine squared. Okay? If you FOIL out your numerator, you're going to get 1 plus 2 cosine plus cosine squared. What's that? What is 1 minus cosine squared? Sine squared. Now, remember a little while ago, we had a problem where we knew that. What's that? The 1 minus cosine squared? Well, that's. I was heading towards that because what I'm seeing here is everybody see how you've got a singular term in the denominator, but you have 3 in the top. Make 3 fractions, and then I would do that. So I have 1 over sine squared plus 2 cosine over sine squared. And Hoppenworth just said this, isn't cosine squared the same as 1 minus sine squared?
Yes.
So can I just say that this is 1 over sine squared minus cosine squared minus a sine squared over sine squared? What I'm doing is I'm taking that Pythagorean identity of 1 minus sine squared and turning it into 2 more fractions.
Yeah.
So, oops. Okay. Whatever. Try to do the next 2 pages on the verifies. No. In the big packets, the next 2 pages, like all block. There's like 14. It's these 2. It starts. The first page starts at number 9. The next page starts at number 1. Try and get some of those done. All right. They're not going to be as complicated as this one, but we'll get there. Okay. Goodbye. See you later. Don't fall.
Don't trip again. Yeah, she fell on her face.
Cats are so
It was
mean.
only because the girl in front of her tripped and then she tripped over.
So, all right. So, are we okay if I do this then?
I don't know, I can't see.
It was very embarrassing.
Become left-handed, please.
Why is it so? Oh, okay. To combine them together.
All I did was started combining them.
Oh.
I have 1 over sine squared plus 1 over sine squared is 2 over sine squared, combine like terms. And then I have a 2 cosine. So now I can combine that a little bit further with the common denominator.
We got a 2.
I don't remember where it gets you. I think I screwed
That
up.
was 2.
Honestly, I think I screwed up somewhere.
Could you pull out a 2?
Anyway, do the next 2 pages on. If you take out the 2,
You get 1 plus, oh.
It seems completely endless. I would, if I went this far without the answer, I would start over because I think I did something wrong.
No
Solution.
solution.
I have to. I might actually. I think I screwed something up.
Oh my god. That's the worst example ever. Does not boost my confidence.
How do you do number 9?
What number is this?
Just try it. Let's try it. Like, I can't figure it out. Let me look at it. You know what the answer is?
You want another one? Not the other, yes, I want to see it.
Okay. 16 problems for tonight, guys.
Yeah.
Yeah.
I'm sorry. I thought I had.
How warm is it outside? Does anyone know?
Like,
It's gonna get to a high of 64 degrees today.
It's like 94 up.
60 degrees outside.
It's not 94.
I thought you were going to say yes.
no, okay.
Okay. I'm trying to figure out if you
What number is this?
49. We have a game today. It's I'm probably gonna have to change my
Oh, I'm an idiot.
It's 1. No, it's not. Just kidding. Yeah, it is. But I'm still a captain.
Seriously. So, hey, I'm an idiot. I made this a lot more difficult than you needed to. You're welcome.
Yeah, it's not gonna be like, I just signed.
Wait, did you just do it again, or did you already have it right now? How to do it?
I'll ask you. If you, would that really like come on this? I don't think so. No, it's I'm killing them.
Don't kill me.
Negative cosine squared is. Wait, you have to point Josie 5 times.
Yeah, I totally forgot to do it this way.
Can you kill puppies when it's with sine and cosine?
Yes.
Above your head?
Yes. So, yeah, I didn't totally forgot that I should have looked at the note on this one before I did it. I even rewrote it this way and crossed it off, saying don't do it that way because you're going to be wrong. I said, oh, duh, it was basically one step. Here, notice we had to start from cosine, we had to get to a secant. Well, I just rewrote it as 1 plus 1 over secant. Got a common denominator right away, and I had secant plus 1 over secant. Got a common denominator here, common denominator, got a secant minus 1 over secant. Multiply by the reciprocal, and you're done. So I apologize. Sometimes it is a lot easier than it looks. It happens. How many? Are you guys reading or watching the what do you call it? Mice and Men?
You already asked.
We get to read this.
I think most of us.
Oh yeah.
Still show us the
You guys not do that, no?
I can't ruin it for you if you've never seen it or read it.
You have to.
Or no,
Connor did it last year.
Mr. Murphy, you should pull up the clip of the movie. Neither of these two know where. Like another video.
He's